Alright, this is your second video on your own. We're going to do scientific notation. This is the second part and we're going to be focusing on very small numbers. Make sure as you're going through this that you pause and rewind as needed. If you miss something, you're welcome to go back. And again, if you have any questions at the end of the lesson, make sure you write them down so that you're prepared for class on Monday. This video is due by Monday. Make sure you're staying on top of those videos and not falling behind. You're going to be using the same foldable in your math journal that you used last time. Make sure you have out your foldable open to your scientific notation page. You should have the first two sections already filled in. We know that scientific notation is a way to write very small and very large numbers, and that it's always written with a coefficient that's between 1 and 10 and an exponent that is positive. Okay, so we're going to take a look today at numbers that are smaller than 1. Open up the tab on your foldable for numbers that are smaller than 1. If you have a number smaller than 1, that doesn't mean negatives. That just means numbers that are very small decimals, like the size of an atom would be a very small measurement. It's numbers that are very long decimals, and this is a way to write those numbers so that it's a little more concise. If you have a number smaller than 1, your exponent is going to be negative. So this is different than yesterday. Yesterday we had numbers larger than 1 with very big numbers. We had a positive exponent, that's above the 10. Today, with very small numbers, we're going to have an exponent that is negative. So taking a look at our example, we have a number in standard form. That just means the way we normally write numbers. And right now we have a number that is 0.000578. This is a very small number. It is smaller than 1. We're going to make this where it has a number between 1 and 10, just like we did yesterday. We're going to move our decimal. So we have a decimal right now. It's right here. We're going to put our pencil on our decimal. We're going to move over, and we want to move it until we have one digit in front of the decimal place. So we're moving 1, 2, 3, 4 spaces over. We're going to put our decimal between the 5 and the 7. Remember, we want a number in the ones place that is not 0. We need a number between 1 and 10. So we've moved our decimal over between the 5 and the 7, so now we have 5.78, and the zeros go away because they're not significant digits. We don't have to write them down. Then, with our scientific notation, we always have times 10 to a power. Yesterday, when we did this, we had a positive exponent. It was the number of spaces our decimal moved. Today, we're going to have another positive or another exponent. We just have to decide what that exponent will be. We moved over 1, 2, 3, 4 spaces to the right. Since we started with a very small number, our exponent is going to be negative 4. So again, we started with a very small number. Anytime you have a small number, you're going to have a negative exponent. And we moved our decimal 4 spaces, so our exponent is going to be a negative 4. Okay. In class on Monday, we're going to work on numbers with standard form and scientific notation, switching back and forth between the two. And if you have any questions, make sure you write those in your journal or in your composition book and that you are ready for class on Monday. Alright, at the bottom of your page or at the side of your foldable, wherever you have space, we're going to do 2 examples with very small numbers in scientific notation. We're going to start with the diameter of an atom. The diameter of an atom, if we're starting from standard notation for our first example of small numbers, is 0.00000000001 meters. Now, it's very difficult to write this number because it's a very long decimal number. It's smaller than 1. To write this in scientific notation, and to make it more concise, we're going to move our decimal to where there is one digit in front of the decimal place. So we're going to move to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. We have the number now where 1 is in front of the decimal place. and we have times 10, we moved 10 spaces to the right. We had a very small number. So when we write our exponent, we're going to have 1 times 10, and since we started with a small number, we're going to have to the negative 10 power. So this diameter of an atom is 1 times 10 to the negative 10 meters. All right, for our second example, I'm going to give you a number in scientific notation. For our number in scientific notation, I'm going to write the size of an amoeba. The size of an amoeba, or a single-celled organism, is 3 times 10 to the negative 4 meters. Now, we need to write this in standard form, so we're going to start with our decimal. Right now we have the number 3. Our decimal is behind the number 3. When we have an exponent that is negative to the negative 4 power, that means we had a very small number. Now, to get a very small number, we're going to move our decimal to the left to write our small numbers. We're going back 1, 2, 3, 4 spaces. We get our decimal, and we're going to fill in the openings with 0. So the size of an amoeba is 0.0003 meters. All right, and make sure you have your notes for class tomorrow. If you have any questions, you can write those down now, and we will see you in class on Monday.